The Shahed 136 is the single most recognizable Iranian weapon used in the Ukraine war. First appearing in late 2022, this low-cost loitering munition changed the character of long-range attacks by making mass drone strikes economically viable. Designed by Iran as an attritable weapon, the Shahed 136 is not a drone in the traditional sense. It is a flying bomb. Once launched, it does not return. Its entire purpose is to fly to a target and destroy itself on impact. The drone's airframe is extremely simple. A delta wing design with minimal moving parts allows it to be built cheaply and in large numbers. This simplicity is intentional. Iran designed the Shahed 136 to overwhelm air defenses through quantity rather than sophistication. Power comes from a rear-mounted piston engine driving a pusher propeller. This engine produces the distinct buzzing sound reported across Ukrainian cities, earning the drone nicknames such as moped drone. While loud, the engine is fuel-efficient, allowing the Shahed 136 to travel hundreds, and in some cases over 1,000 kilometers depending on payload and flight profile. Guidance is primarily GPS-based, using commercially available navigation components mixed with military-grade systems. This hybrid approach allows Iran to bypass sanctions while maintaining acceptable accuracy. Although not precision-guided in the Western sense, the Shahed 136 is accurate enough for area targets such as power stations, ammunition depots, radar sites, and urban infrastructure. The warhead is typically estimated between 30 and 50 kilograms of high explosive. While smaller than cruise missile warheads, it is still devastating against soft and semi-hardened targets. The true danger comes not from one drone, but from dozens launched simultaneously. Russia adopted the Shahed 136 rapidly, redesignating it as the Geran 2. Launch methods include truck-mounted racks, allowing rapid deployment and mass launches. This tactic forces defenders to expend expensive surface-to-air missiles against a target costing a fraction of the interceptor's price. Ukrainian air defenses eventually adapted, using anti-aircraft guns, man-pads, electronic warfare, and even small arms fire. However, every interception still costs time, manpower, and resources, exactly the pressure the Shahed 136 was designed to create. Strategically, the Shahed 136 demonstrated Iran's expertise in asymmetric warfare. It proved that a relatively simple weapon, when deployed at scale, could disrupt modern air defense systems and strain an advanced military's logistics. The Shahed 136 did not win battles on its own, but it reshaped air defense economics. Its impact on the war goes beyond physical destruction. It forced Ukraine and its allies to rethink how they defend against mass, low-cost aerial threats. The Shahed 131 is the smaller and lesser-known sibling of the Shahed 136, but it plays a critical supporting role in Iranian drone warfare. While overshadowed by its larger counterpart, the Shahed 131 offers flexibility, stealth advantages, and lower production costs. Physically smaller, the Shahed 131 features a compact delta-wing design optimized for shorter-range missions. This reduced size allows for easier transportation, concealment, and deployment. In some cases, it can be launched from improvised platforms with minimal infrastructure. The engine is similar in concept to the Shahed 136, but scaled down. This results in lower speed and payload, but also a smaller acoustic and radar signature. In contested environments, this makes detection slightly more difficult, especially when launched alongside larger drones. The warhead is estimated to be around 10 to 15 kilograms. While this limits its destructive power, it remains more than sufficient for damaging radar systems, communication nodes, fuel depots, and lightly protected infrastructure. One of the Shahed 131's key strengths is cost efficiency. By using even fewer materials and simpler electronics, Iran can manufacture these drones in high volumes. This makes them ideal for saturation attacks, decoys, or probing missions designed to reveal air defense positions. In Ukraine, Shahed 131 drones were often used in mixed attack waves. Larger Shahed 136 drones would draw attention and interceptor fire, while smaller Shahed 131 units slipped through to strike secondary targets. The guidance system again relies on GPS and inertial navigation, with limited terminal correction. Accuracy is adequate for static targets, but less effective against moving ones. This confirms the drone's role as an infrastructure and suppression weapon, rather than a tactical battlefield killer. From a military perspective, the Shahed 131 shows Iran's understanding of layered drone warfare. It is not designed to replace the Shahed 136, but to complement it, adding depth, confusion, and redundancy to drone strike packages. While individually less destructive, the Shahed 131 contributes significantly to overall campaign pressure. Its presence forces defenders to treat every incoming object as a potential threat, increasing fatigue and resource drain. Unlike the disposable Shahed drones, the Mohajer 6 represents Iran's move into reusable, armed, unmanned aerial vehicles. It bridges the gap between reconnaissance drones and strike platforms, offering surveillance and limited precision attack capability. The Mohajer 6 is a conventional UAV with a high aspect ratio wing, rear-mounted propeller, and tricycle landing gear. This design allows it to take off and land from prepared runways, giving it greater endurance and reusability. Equipped with electro-optical and infrared sensors, the Mohajer 6 can perform intelligence, surveillance, and reconnaissance missions. These sensors allow it to detect vehicles, artillery positions, and troop movements, feeding data back to operators in near real time. What makes the Mohajer 6 especially dangerous is its ability to carry guided munitions. Typically armed with QAM series precision-guided bombs, it can strike targets with far greater accuracy than loitering munitions. In Ukraine, Mohajer 6 drones were reportedly used for battlefield surveillance and limited strike roles, particularly against artillery and logistics targets near the front lines. However, their survivability proved lower against modern air defenses compared to expendable drones. The drone's data link range is limited, meaning it often relies on line-of-sight or relay systems. This constraint reduces its effectiveness in deep strike roles, but keeps it relevant for tactical operations. From a strategic viewpoint, the Mohajer 6 shows Iran's intent to offer a complete drone ecosystem, from one-way attack drones to armed ISR platforms. This versatility makes Iranian drone exports attractive to nations seeking cost-effective alternatives to Western UAVs. Although not decisive in Ukraine, the Mohajer 6 demonstrated how even modestly armed UAVs can influence battlefield awareness and targeting efficiency. The QAM-5 precision-guided bomb represents Iran's effort to turn relatively simple drones into accurate strike platforms. Unlike loitering munitions, the QAM-5 is not a suicide weapon. It is an air-dropped munition designed to be released from drones such as the Mohajer 6. Visually, the QAM-5 resembles a small glide bomb. It features a compact body with guidance fins and control surfaces that allow it to adjust its flight path after release. This gives it far greater accuracy than unguided bombs or rockets. Guidance is achieved through a combination of electro-optical, infrared, and laser guidance variants. This flexibility allows operators to adapt the weapon to different battlefield conditions. In clear weather, electro-optical guidance enables visual confirmation of targets, while infrared variants are effective at night or through smoke. The warhead is relatively small compared to traditional air-dropped bombs, but this is intentional. The QAM-5 is optimized for point targets such as artillery positions, radar vehicles, command posts, and lightly armored vehicles. In the Ukraine conflict, Iranian-supplied QAM munitions allowed drones to perform precision harassment rather than mass destruction. While a single QAM-5 strike might not flatten a facility, it could disable key systems or vehicles with minimal collateral damage. This type of weapon highlights a shift in warfare. Drones no longer merely observe the battlefield. They actively shape it. A single UAV armed with QAM-5 bombs can loiter for hours, identify targets, and strike when conditions are optimal. However, the QAM-5 also has limitations. It requires the launch platform to survive long enough to release the weapon, making it more vulnerable to air defenses than expendable drones like the Shahed 136. Despite this, the QAM-5 demonstrates Iran's growing confidence in precision strike technology. It transforms modest drones into credible battlefield threats and shows how relatively inexpensive systems can challenge traditional artillery and air power. The Shahed 238 marks a major evolution in Iran's loitering munition design philosophy. Unlike earlier Shahed drones powered by piston engines, the Shahed 238 uses a small jet engine, dramatically increasing speed and reducing interception windows. Externally, the Shahed 238 retains the familiar delta wing shape, but its performance is radically different. The jet engine allows it to approach targets much faster than propeller-driven drones, making traditional air defense responses more difficult. Speed changes everything. While earlier Shahed drones relied on overwhelming defenses through numbers, the Shahed 238 adds the element of reaction time pressure. Defenders have far less time to detect, track, and engage the drone before impact. Guidance is believed to include inertial navigation with satellite direction. Similar to earlier models, but with improved resistance to electronic warfare, Iran designed the Shahed 238 specifically to counter lessons learned from Ukraine, where electronic jamming reduced the effectiveness of older drones. The warhead is comparable in size to the Shahed 136, meaning it still delivers a powerful explosive effect against infrastructure and hardened targets. Although confirmed battlefield use remains limited, the presence of the Shahed 238 signals Iran's intent to stay ahead in the drone versus air defense arms race. Even the possibility of its deployment forces defenders to adapt. Strategically, the Shahed 238 represents escalation without complexity. Instead of building stealth drones or advanced cruise missiles, Iran opted for speed and simplicity, an approach that keeps costs low while increasing lethality. In the context of Ukraine, such systems highlight the future threat environment: faster, cheaper, and harder to stop aerial weapons that blur the line between drones and missiles. The Arash-2 is one of Iran's most extreme long-range loitering munitions. Designed for strategic-level strikes, it is larger, heavier, and more powerful than the Shahed series drones. Iranian officials have openly described the Arash-2 as capable of reaching distant, high-value targets. This makes it less of a battlefield weapon and more of a strategic strike system. The drone's airframe is built for endurance. Large wings and an efficient engine allow it to travel enormous distances, making it suitable for deep strikes against infrastructure far from front lines. The warhead is believed to be significantly larger than that of the Shahed 136, giving it the destructive potential to damage hardened facilities such as power plants, industrial complexes, and fortified command centers. In Ukraine, the Arash-2's relevance lies as a deterrent and escalation tool. Even limited deployment forces defenders to protect targets previously considered safe from drone attack. Unlike smaller drones used in mass attacks, the Arash-2 is likely deployed selectively due to its size and cost. Each launch represents a deliberate strategic decision rather than routine harassment. The Arash-2 embodies Iran's doctrine of long-range asymmetric strike, using relatively simple technology to threaten critical assets at great distances. Its psychological impact may outweigh its physical use. Knowing such a weapon exists and could be deployed adds pressure to already stretched air defense networks. The Shahed 107 represents a lesser-known but important element of Iran's drone ecosystem supplied to Russia. Unlike the widely publicized Shahed 136, the Shahed 107 is believed to serve both reconnaissance and limited attack roles. Physically, the Shahed 107 is smaller and more compact, optimized for battlefield-level operations rather than deep strategic strikes. Its airframe emphasizes endurance and stability over payload size, allowing it to loiter above contested areas for extended periods. The primary role of the Shahed 107 is believed to be target acquisition and battlefield surveillance. By identifying Ukrainian positions, artillery batteries, and air defense systems, it enhances the effectiveness of other strike assets, such as artillery, missiles, and loitering munitions. However, the drone is also capable of carrying a small explosive payload. This gives commanders the option to use it as a one-way attack drone when a high-value target presents itself unexpectedly. In the Ukrainian conflict, drones like the Shahed 107 contributed to the broader intelligence network supporting Russian strikes. Even when not directly attacking, they enabled more accurate and timely fire missions. The guidance system combines inertial navigation with satellite positioning, allowing it to operate in GPS-contested environments with reduced accuracy degradation. This resilience is critical in modern electronic warfare-heavy battlefields like Ukraine. While not as destructive as larger loitering munitions, the Shahed 107's value lies in persistence. A drone that can stay aloft, observe and strike opportunistically adds constant pressure to frontline forces. From a doctrinal perspective, the Shahed 107 shows how Iran designs drones not as standalone weapons, but as nodes within a larger kill chain, linking sensors to shooters in a cost-effective way. While not a complete weapon system deployed directly, Iranian Rad 500 precision warhead technology played a behind-the-scenes role in improving strike accuracy and effectiveness. The Rad 500 program focuses on lightweight composite materials, compact guidance systems, and efficient explosive design. These technologies are transferable across multiple weapon platforms, including drones and missiles. In the context of Ukraine, evidence suggests that Iranian expertise influenced the design and modification of drone warheads used by Russian forces. This includes improved fragmentation patterns and optimized explosive yields for infrastructure targets. The advantage of such technology lies in efficiency over raw power. A smaller warhead that detonates precisely can cause more functional damage than a larger, poorly targeted explosion. Iran's experience with sanctions forced it to innovate using limited resources. The result is compact, adaptable warhead technology that can be integrated into a wide range of platforms. This technological transfer does not rely on shipping complete missiles or bombs. Instead, it spreads knowledge, making it harder to track, sanction, or intercept. From a strategic viewpoint, the Rad 500 highlights how modern warfare is not just about weapons deliveries, but about expertise. Even partial knowledge transfer can significantly increase a partner nation's strike capabilities. In Ukraine, such improvements made drone attacks more disruptive by targeting specific infrastructure components, rather than relying solely on blast damage. One of the most critical Iranian contributions to the Ukraine war was not a single weapon, but a suite of navigation and guidance technologies integrated into drones and loitering munitions. These systems combine inertial navigation units, satellite receivers, and basic terrain-following logic. While not as advanced as Western equivalents, they are robust, cheap, and resistant to partial electronic interference. Iran designed these kits to function even when GPS signals are degraded or jammed. This resilience proved valuable in Ukraine, where electronic warfare plays a central role on both sides. By supplying guidance kits rather than complete weapons, Iran enabled rapid local assembly and modification. This allowed Russia to adapt drones to specific mission profiles and available components. The importance of guidance systems cannot be overstated. Accuracy determines whether a drone is a nuisance or a serious strategic threat. Iranian guidance technology transformed simple airframes into reliable strike platforms. These systems also enabled pre-programmed flight paths, allowing drones to approach targets from unexpected directions and altitudes, complicating air defense planning. From a military perspective, guidance kits represent force multiplication. A basic drone with reliable navigation becomes a persistent threat, capable of striking infrastructure with repeatable accuracy. In Ukraine, this capability forced defenders to protect a much wider range of targets, stretching air defense coverage thin